Hello, everybody, and welcome back to another Scaleway Sessions. I am your sometimes and forever host, Dan. I'm the head of developer relations here at Scaleway. I am joined by my partner in crime, as always, Diego, the man behind the scenes, the man on the soundboard, the man suffering from allergies. There it is. So we are doing another special edition like we do every month, not always on the same part of the month. We do every month. We do Call Dr. Kube. Call Dr. Kube is happening right now. That's why you're here. You're interested in Kubernetes. You're interested in getting your Kubernetes questions answered. And we have just the man to answer them. Our special guest today, playing the role of Dr. Kube this month, is Sacha Bernheim. Would you like to say hello to the audience, sir?
Hello everyone, I'm Sacha Bernheim. I'm a SRE specialized in Kubernetes. I've worked with Kubernetes for 2 years now, and so I hope I will be able to help you with your questions today.
Excellent. Well, thanks so much for coming through. We actually had the pleasure and the honor of inviting Sacha to a Kube Talks here in Paris not too long ago. Isn't that correct?
Yeah, I was doing a Kube Talks a month ago where I presented an operator, a Kubernetes operator I developed with a colleague. I've been developing it for a few months now. It's about running your Terraform workflows inside Kubernetes. Why is that? Is because when you start to have growing code bases in Terraform, it's kind of hard to know which one is applied, which one is up to date, which one you have to reapply because someone did something manually in your cloud console. And so we do not have currently like a good operator available in the community, but you have like software as a service solutions that works perfectly, but they are way too expensive for us and our clients. So we decided to try and create this Kubernetes operator to help with our project and to help the community because we feel that it's something that is needed.
Excellent. Well, I mean, this is the sort of thing, necessity, breeding the mother of invention, and so on and so forth. Really, really appreciate you doing the work and putting that out into the open source world so people can benefit from that. We'll definitely circle back on that a little bit later to learn more about that, to learn more about how it can be used and what the use cases might be and so on and so forth. And we'll talk about some other stuff as we go through today as well. So if this is your first time joining us, either for Scaleway sessions, in which case, welcome. We've been doing this now for a few months. Every Friday, we hang out, we have some fun, we learn some things, right? If this is your first time attending Call Dr. Kube.
Yes.
Call Dr. Kube is where we just get somebody who knows something about Kubernetes to answer questions, right? Where do we source these questions? We source them from you, from the community. So we gather these questions from our community Slack, from our support team, from trawling around on Stack Overflow and on Reddit, for asking our specialists what kind of questions do they get asked when they're out there working with clients, working inside of their places of employment, and so on and so forth. So we, on our side, we assemble a whole list of questions, and then we send them off to Dr. Kube, and Dr. Kube goes, these are the 4 I want to answer. And then I don't ask those ones. I ask the ones he doesn't want to answer. No, No, but the idea is that we're going to bring you the useful knowledge and the interesting stuff, and then along the way, we'll end up talking about how to smash capitalism or something, which is a theme that comes up fairly often on Scaleway sessions. I think more than would be statistically probable. But there we go. So why don't we dive right in, if that's okay with you, Sacha? Can I ask the first question?
Yeah, of course.
All right, so the very first question, we talked about this a little bit before we started, but I wanted to talk a little bit about the why of it. So the answer to the question is basic, but the why of it, let's get to that. Question is, are there visual tools you recommend for managing a cluster? Kube versus OpenLens, for example. There's a whole Reddit thread that we found this on. Now, Sacha, your answer here is that you've never used a visual tool, so can't recommend. But let's get into the why of that. Why haven't you used a visual tool?
Well, when I first learned how to use Kubernetes, I didn't know any of these tools. And I was working with a senior SRE, of course, on my project, and he wasn't using any of these tools. So when I learned how to use Kubernetes, I never used OpenLens or K9S or whatever other tool. I only used kubectl CLI. And afterwards, so I learned for 6 months. I've worked with only kubectl CLI, and the first time I was introduced to one of those tools, I was like, okay, it's nice, but everything you're doing with this, I already know how to do with only the kubectl CLI. So I don't feel the need to use one.
Right, that's fair. So the answer is, don't use one because I've never used one.
Yes.
But it's not, it's not a contest of who can be the better technical person. It's not a contest of who's the most experienced engineer. All of these tools have their place. They have their purpose.
Of course, a lot of colleagues at Padok use K9S, I think, and it doesn't mean that they are less of an expert than me. Probably some of them are better with Kubernetes than me. It's just that they're used to it.
Right.
And I think the whole point of those tools is just find your way to be as productive as you can. And if they are more productive using one of those tools, that's fine by them. But for me, I prefer to use only kubectl CLI, because I feel like now I will have to learn how to interact with Kube all over again if I start using one of those tools.
I saw your face with the kubectl then.
Yeah.
We've had always have this discussion about how do you pronounce it?
Yeah, I think Dan did a talk at KCD about that.
It got to that point. Yeah.
This is my favorite part. Whenever we start talking about Kubernetes, it's okay, hold on, stop. How do we pronounce this word? Every time.
Kubectl, kube control. As long as we understand each other, that's what matters. And I think that your whole talk at KCD was about that.
Yes, exactly.
So it seems like this discussion about using a graphical interface is sort of similar to when you decide to use VI for Emacs instead of modern visual interface like Visual Studio or Visual Studio Code. You just got used to it, but you are as productive with it because that's part of your workflow. You know how to use to do it.
I kind of agree with that. I like the comparison because I started coding for this job on VS Code, and then I had some colleague telling me oh, you should use Vim. It's so much powerful. You're gonna be a lot faster with it. And I tried. I actually tried Vim, but it's so hard for me because I'm used to VS Code and I have so many more things to use to use the full power of Vim that I prefer just to click on VS Code. And it's the same sometimes I'm just doing pair programming with some person that are used to some shortcuts in VS Codes that I never used because I never looked for, and they're like, oh, so you're doing this manually, you should click on Control-Shift-K, select with the arrow and do this. And I'm like, okay, you're doing magic, it's awesome, but if I have to remember this, it's gonna take me a lot more times. I'm doing it my way.
You need to erase some old content in your brain.
That's it.
Yeah, exactly. If you got to do a Konami code just to start search and replace, then maybe the problem's not you. It might be the tool, right? I'm a Vim user. That's because I've been using VI since the 1990s. And actually using any of the, I tried using VS Code multiple times because everybody's like, it's amazing, it's got the plugins, and especially I work with a lot of documentation. And if I can write Markdown on one side and have the render right beside it in real time, and everybody, I understand the value of that. Also, if you're doing, using Gitpod and doing development in cloud environments and whatnot, they're just going to give you a VS Code right in your browser. I understand why that is. I'm not debating the validity of the tool. But every time I sit down in front of VS Code, 5 minutes later, I'm just like, well, time to open a term.
Right. Yeah, it's a matter of what you're used to and how you feel more productive, right?
Exactly. And speaking of, actually, so we had Arthur in the comments. So, hi, Arthur. Nice to see you. Hey. Who is a previous Dr. Kube, actually.
A former colleague of mine, actually.
There you go. And he says the best combo is kubectl and JQ.
Yeah, I completely agree. we worked together a lot, and so I can only agree with him.
Right. Well, so there you go. So for those of you out there, again, you're thinking what is kubectl, kubectl, whatever. The second part of that, JQ. like every is a first time for everybody, right? What's JQ?
JQ is a CLI tool which can help you like navigate and query JSON inputs. And so when you're working with kubectl, you have, or kubectl, or I don't know, I'm gonna go with kubectl. But when you're working with kubectl, you can ask for the output of the command to be in JSON-like format. And so afterwards, you can like pipe this into JQ commands to only get the information you need. Because what actually kubectl does is just it wraps calls to the Kubernetes API, because that's what Kubernetes is. It's an API. So actually, kubectl is kind of a visual tool to help managing clusters, because I really don't want to like communicate with my cluster using curl because the API is way too complicated. But it's so kubectl is able like to make API calls to your cluster and get the output of this call as JSONs. But those JSON are going to be like enormous for depending on the query you're running, and so JQ can help you with that.
Yeah, perfect. Thank you so much. For those of crusty old system administrators out there like myself, JQ is kind of like set and awk, but for a very specific data type.
Yeah.
So there we go.
That's it.
That's it. Perfect. All right, put a pin on that one. Okay, well, thank you. You know, again, this is the whole thing, right? We ask a question, we go down some rabbit holes, we see what happens. We do have lots more questions and only a brief amount of time to get through them. So with your permission, maybe we'll just jump right to the next one. And these questions are in no specific order, right? We just kind of comb the net and we pull out some things and we start looking at them and see what happens. So one of the questions, and I thought this was an interesting one, how do you avoid or gracefully handle race conditions in distributed systems? That already is a big question. Like we talk about Kubernetes, we talk about distributed systems, how race conditions in distributed systems. We could like in some ways just do a whole hour-long talk about race conditions in distributed systems, right? But then the second part of the question, which is a lot of fun, right, is have you seen any really weird ones?
Yeah. So rate conditions happens when like outputs of a command depends on the order it was started. And it can happen a lot inside Kubernetes, because Kubernetes works is asynchronous. So basically, you ask stuff to Kubernetes, you know at some point it will happen, it will do something, but you don't know when it will happen. So a race condition can happen a lot inside Kubernetes, and I think like the only way to avoid them is just to really think about your system design. Like I don't really have any more inputs about this, but have I already seen real weird ones? The answer is yes. And so I'm spoiling a bit the talk that Arthur will do at the next Kube Talks, but it was about secrets management inside Kubernetes. For those of you who work in a cloud native environment and use a secret manager, you've probably have heard of external secrets. And so basically external secrets, it's an operator, and well, you can define like external secret resources inside your cluster, saying like I want to create a Kubernetes cluster which will fetch a secret inside a secret manager with this version. And what happened is that when we deployed a new version of an application, we changed the definition of the external secrets, saying that you have to get the new version of the secret. But the application deployed itself before the external secret operator did his job and updated the secret. So the application was deployed, but it was using the old version of the secret. But when we were going like with kubectl to check which secret was used, it was saying, yeah, the version of the secret I synchronize is the one you asked me, the v3 and not the v2. But actually, the application started with the v2 secret.
Right. That must have been fun to debug.
Yeah, it was fun to debug. Actually, to be completely honest, at some point when you don't understand what's happening, you just like kubectl rollout deployment and hope for the best. So that actually completely solved the issue, because the secret had been synchronized since then, and so the application deployed itself with the right version of the secret, and afterwards we tried to understand what happened. The first time we were like, okay, why not? The second time we were like, okay, this is weird, we have to investigate.
Right.
And that's when we understood that the issue was with the external secret operator.
Right. Yeah. No, for sure. For sure. Those are the sorts of things that, I say it's been fun to debug, but at the end of the day, these are the sorts of things where you're going to have, for example, some tooling that's going to give you, some understanding about what's deployed, and have some observability tooling. It's maybe going to show you some statistics on things. You're going to have some traces, and you're going to go look through your traces and whatnot. But stuff like this, where it's these weird little race conditions where everything reaches the end of its pipeline.
Yeah.
Right? Like, it's one thing if it stops. It's one thing if you get an error. It's one thing if like a test fails. It's one thing if, we tried to do the build artifact, and during the build process, the compilation failed, right? We tried to deploy it to this endpoint. The endpoint said 500. Okay, you know what I mean? When you reach these points, and your tooling, whatever it is that you've got, is going to be able to say, hey, we were expecting this and we got this instead. But when you're like, no, all the lights are green, the application's been deployed, right? It's there, it's running right now, right? And you're like, eh? That's when you got to go, okay, well, it's time to, start going through some logs with a fine-tooth comb. It's time to start, manually hitting endpoints and trying to figure out what happened, right? Getting your hands dirty with
worst case scenario, you try to exit inside the pod.
Yeah, oh my God, yeah. Let's go SSH into some pods. That's normal and good.
Yeah.
All right. Oh, I think is my video chopping up?
Maybe.
Yeah, I think you froze a bit.
It is. That's weird. I wonder why.
But your audio is fine. So
my audio is fine. Okay. All right. Well, why not? Computers, right? Let's test and prod.
Yeah. So meanwhile, yeah, I wanted to ask you. Well, first of all, I'm new to this cloud world. I come from the web development world, specifically from the client side. Right now, I'm wearing my classical Chrome Dev Summit 2018 t-shirt. So yeah, this has been a new journey to me. And one thing that I've been wondering is, how the hell do networks work in Kubernetes? Because as soon as I understood that part in the Docker world, I think that opened my mind to these new things that I could actually achieve. Now, as I'm slowly stepping into the Kubernetes world, I'm wondering, what should I expect? Is it a huge thing that's hidden behind one door, or is it just the same? Or what should be the approach that I should have?
Yeah. So networks in Kubernetes work kind of the same as in Docker, but it's a bit more complex because you have also in between nodes communication, whereas on your local computer you only have one node, which is your local computer.
Yeah.
I think when you're starting with Kubernetes, and that's the whole beauty of Kubernetes, you don't have to worry about networks at all. It just works. And that's the beauty of Kubernetes. It's just it abstracts so many complex things that works at the kernel level that maybe 10 person on the planet really understands, but makes it available for everyone. But if I go a bit more into details, Basically, it works at the kernel level by leveraging what we call network namespaces in Linux. So, for instance, when you're installing Linux on your computer, you have like a whole network that is installed in your computer where you have networks interfaces and routing tables, and you can add or change those network interfaces and routing tables. But and so the network names, so for everything that runs on your computer, those network interfaces and routing tables are the same. But network namespaces kind of change that because network namespaces is a whole virtualization of a whole network that will run inside your that will run in your kernel. So basically, when you start a network namespace, the network namespace will have its own network interfaces, its own routing tables, which will be completely independent from the one of your computers and from the one of another network namespace.
Right.
And the beauty of it is that you can connect a network interface from one network namespace to a network interface from another network namespace. And so that's how everything works under the hood. Now that we understand this, basically, each time that you will start a pod inside Kubernetes, at the node level, it will start a network namespace, which will be the network namespace of your pod. And we will connect a network interface of this pod to the network interface of your node, so the root network interface of the computer.
Right. Okay, so one node can create several namespaces for each
Yes,
pod.
that's it.
Or
It's
several
one
for each pod
namespace,
or one per pod?
one per pod.
All right.
It's one per pod. And so we link those namespaces to the root namespace of the machine.
Yeah.
And then those namespaces can connect to each other, leveraging another kernel function, which is called a bridge. And basically does the same thing as you would do with a local network in your house. And so with this connection of namespace to network interfaces and bridges, basically one pod can communicate to another one as long as they run on the same machine. And so that's basically how it works in Docker when you run Docker Compose. But what's added in Kubernetes is that, well, when you run Kubernetes, you don't only have one node, you can have multiple ones. And so each one of your nodes will act as its own gateway, in the sense that you already know a gateway. And so basically, each pod, each namespace has its own private IP. And so each time you will, your pod will try to communicate with one private IP. It will first go to the bridge, so on the local machine, on the root network of the machine.
Right.
It will check if it only has to go into the node with the bridge connection. Otherwise, it's the gateway function that will be used. And so the gateway function will know that, oh, I want to go to this pod IP, which is not on my machine. I have to send it to this machine, and this machine will handle it. And then it goes to the other machine, which is probably the one where the pod you're trying to contact is running. And then it will work locally as we've seen before. And so that's how it works. It's a lot of kernel functions with nodes acting as gateways. But and so as I said, this is a lot of complex stuff. So Kubernetes had the amazing idea of making this whole thing what they call an open standard, which is called CNI, Container Network Interface. And so basically CNI is just an API contract saying if you are developing a tool which can add a pod the way we just saw, so creating the namespace, linking it to the root machine, creating the bridge, and adding the routing table for the gateway. And you can also do the exact opposite operation by removing this pod. Well, you can actually create what we call a network plugin and handle all the network inside a Kubernetes cluster. And so basically, when you start using Kubernetes, when you will deploy the Kubernetes, it will come with a network plugin. So if you're running Kubernetes in the cloud, each cloud provider use its own default network plugin. If you're working on premise, you will have to choose one. But basically, you only have to kubectl apply the network plugin you want to work with, and everything works for you. You don't have to worry about it.
Well, that's great.
Yeah.
So it's basically Linux networking. Who knew?
Yeah. It's always Linux at some point.
Yeah.
Well, so this, I mean, if people who may have not worked with this in the past specifically, but may have encountered at least some of these terms, this idea of like a bridge, this idea of having network interfaces and whatnot. And if you've ever, for example, physically plugged a cable into something else, you got a piece of Ethernet and it's got a little RJ45 on the end of it, and you boop, plugged into a switch or something like that. Well, that's a network interface, right? And so you're plugging that, and then the switch has got a backplane in there. It's going to be doing some routing. That's going to be, layer 2 data link layer routing, right? Because it's a local area network, but the concepts are the same at the end of the day, right? So this idea of having interfaces and having routing and going and figuring out what is the lowest possible layer, what is the least distance that a particular packet has to go to get to its destination, right? Is it something that's literally right beside me? Does it have to traverse into another layer of the network stack? Do we have to do internetworking? Do we have to go like onto the internet and then come back, so on and so forth? And it's all of these concepts just in a little virtual thing that's happening in the kernel.
Yes.
Right?
Yeah.
That, and if you've ever used like VirtualBox, for example, right? Which, was super, super popular for a long time before Docker kind of ate VirtualBox's lunch, right? But you ever used VirtualBox and had to configure network interfaces, and you'd have the selection of them, and one of them would be bridge, another one would be like virtual, another one would be local link only, right? The same thing. It's just that virtualization, and then we're exposing sort of what's happening underneath. If you're running VirtualBox on a Linux machine, you're exposing some of these kernel elements, right? These capacities of the kernel, depending on which era of Linux you're talking about. Some of it was more complicated virtualization than others before this was properly exposed in the Linux kernel. But you don't have to necessarily be as you said, Sacha, a Kubernetes or a networking expert to make the networking parts of Kubernetes go, which is kind of the interesting part about it. Yeah,
That's
for sure.
The same goes with containers. Like containers only leverages like really deep stuff inside the kernel, like C groups and user spaces and all these kind of words you don't ever want to hear about. But like when you use Docker locally, you just have your Docker file and you do Docker run, Docker build, and that's it. But underneath, tons of stuff are happening. But as a user of Docker, you don't have to care about it. It's the same goes with Kubernetes. Like if you're only like using Kubernetes as a power user, so basically you just created a cluster inside a cloud provider, you don't have to care about it.
Great.
Yeah,
so how does all this relate with service meshes?
Okay, so service meshes are a bit different, but it's but it's interesting because so as you know, you come from web development. So like years ago, we were only or mostly doing a monolithic application, and now it's like there is the whole movement of microservices. Service mesh come from this because when the idea behind like splitting a monolith into microservices is saying, well, each team of developer can only focus on the business logic that is their own without having to care about the other business logic blocks.
Right.
But the fact is that when you were deploying a monolith, You were also deploying maybe like some endpoints to get metrics for observability. You were also maybe deploying something for authentication and authorization, and maybe you were deploying also an added layer of security. And the issue is that, okay, with microservices, we like split it up the whole business logic, but that means that in each and every new block, we have to re-implement the metrics endpoints for having observability. We have to re-implement also the authorization layer and the security layer and all that. So it's painful, and we actually added work when we were actually trying to reduce it or optimize it. And so that's where services mesh, that's why service mesh were invented. It's because service mesh, as they work today, it's kind of changing right now, but as they work today, basically they inject a proxy, so a container inside your pod that will handle all of this for you. And so basically, this proxy, you can like get metrics from this proxy for checking how much resources your pod is using, how many how many requests it's getting. You can add authentication and authorization policies that will be like spread across your whole service mesh. You have an extra layer of security because we talked about networks inside Kubernetes, but communication between pods does not handle TLS communication by default. With service mesh and the use of service mesh, it is available. And so that's what a service mesh is. It's something that will connect kind of everything, the whole network will go through the service mesh, and so you will be able like to have increased observability, increased security, and to be able like to do the configuration only in one place and get it deployed everywhere.
It is. We are well into allergy season.
Yeah.
Here in France, especially the northern half of the country. So everybody, we were all blowing noses, we're all coughing. I was actually out just earlier today. I'm not in Paris today. I'm actually out in the countryside. And if you think it's bad in Paris, it was snowing outside.
What?
But it wasn't snow.
Oh.
So I'm feeling it. Yeah.
Yeah,
So
maybe I
that-
mentioned this in a previous episode, but I'm not from Europe, so I'm not used to these weather conditions and also to these kind of plants over here. So when I got here, it was so weird to me that during 4 months of the year at least, I just got constant flu.
Yeah, just nose
then-
running, eyes watering all the time.
Then probably last year, I realized, hey, this may have something to do with these allergies people talk about.
Yeah.
Yeah, it's like that emoji, that emoji, right?
And so to go back to service mesh, I think what's really interesting and how we can link this to networks we were talking about before is that so service mesh is an extra network layer that we add because like we run proxies in each and every one of our pods. Istio is actually the most famous implementation of service mesh, I think, and they released like a beta version a few weeks ago where it actually works without sidecars. I don't know exactly how, but kind of interesting to know. And if you're only interested in like the added layer of observability and security for TLS communication between services, there is actually a network plugin. So from the other question, that actually now does that out of the box directly at the network level. It's called Cilium. I think it's the network plugin that is used by default by Capsule. And so this network plugin leverages also other weird technologies from the kernel. For your information, it's called eBPF. eBPF basically lets you run custom kernel code at runtime without needing to recompile the kernel. A bit weird. And so what it's able to do is that we can like listen to each kernel event, which is a lot. But if you listen carefully to this kernel event, you have all the information you need because everything is happening in the kernel. So if you want to know how much CPU your app is using, it's actually a kernel. You can infer it from kernel event. If you want to know how much request your app is handling, you can also learn it from kernel events and this kind of stuff. And so that's how this network plugin actually adds this observability layer out of the box directly at the network level. And so it's not released yet, but it should be soon for the TLS communication in between pods. It will also be done at the network level. And so this network plugin will also let you like add other security layer. For instance, if you want to make sure that some files are not touched inside the root machine, like in case of attacks and this kind of thing, it will be like doable directly at the network plugin level, which is I think kind of awesome.
Yeah, for sure. And I like that you evoked eBPF, right? This to me is I don't want to call it magic, right? It's nothing magic. It's computer science. It's programming. Yeah. It's, you know what I mean? It's engineering. But it's really, I think, a really interesting way to think about what we can do in terms of running code, where we can run that code, and exposing things which are exposing elements of an operating system, core elements of an operating system, in a way that would normally be possible, right? Most people, workaday developers such as myself, right? When we're sitting down, we're sitting in VS Code or Vim or whatever it is we're doing our jobs, right? And we're writing some code and it's going to be some sort of, I don't know, it's an interpreted language, or maybe it's going to be statically compiled, but writing some Rust, whatever, right? And it's going to make a binary, and that binary is going to go off and it's going to do some, I don't know, ETL. Who knows what it's going to do, right? Very few people on a day-to-day basis, professional computer programmers, people paid to computer, are mucking around with kernels. I mean, on a daily basis, right? eBPF kind of opens the door to that, right? Where we can go, you know what? We can provide a facility to run sandboxed code, sandboxed applications inside of the kernel space, right? Like it's a privileged context, right? And I think that's really cool. You don't need to write a kernel module, which is how we used to have to do it. And I have written kernel modules, so that's the whole world. That's how we used to do it. Kernel modules come with a whole raft of security problems, unsigned code, you name it. It was the best of a bad situation until eBPF came along. I mean, we could do a whole thing on eBPF. I don't want to sidetrack this conversation, but I think eBPF is super exciting. And you know what, Diego? That could be a cool theme for a future Scaleway sessions. We'll get somebody in to talk about eBPF because it's super cool. But we'll put a pin on that for now, or else we're gonna go down that. We're gonna go all the way down that one.
Totally.
Yeah. Excellent. Okay. So we talk about how networks work. How services might want to maybe communicate with each other, right? So we've talked about networks. We've talked about service mesh. And how service mesh can enable these sorts of things. We're kind of going up the stack at this point, right? We started at the very low level. We're kind of moving up, which is really cool, right? So once we've got our things deployed, once we've got our services talking to each other, once we've got our, so on and so forth, I would actually like to sort of dive into a little bit and talk about how do we actually deploy our apps now on top of these things. We've got our building blocks. We've got the Kubernetes. we've got the control plane going, we've got the service mesh going, we have the infrastructure to make applications go. But we haven't actually made any applications go yet. Right? So why don't we talk, I don't know, what do you want to talk about? Let's talk about secrets. All right. So even before we can get to the point where we're deploying the application, we have to be able to manage bits of data, passwords, keys, you name it. We say secrets, some of it is secret, and some of it's just instance-specific information, right? How do we manage that? And how do we ensure that when we're ready to deploy our applications into this beautiful, wondrous infrastructure we've got, how are we storing this instance-specific information? How are we storing these secrets, and how are we getting them into the places they need to be so that we can deploy our applications?
First of all, you have like tons of ways to do that inside Kubernetes. So Kubernetes, they have a resource called secrets that are actually not really secrets because, as you may know, it's only base 64 encoding. So
but it's well ROT 13 it. It's fine. Don't worry about it.
It's just like if someone is like looking over your shoulder at work or in the subway, you won't be able to decode it, but it's basically not encoded. So it's not like enough to like transport your secrets inside the cluster, because when you will deploy, because that means that if you only leverage this system at some point, because you probably are using a Git provider somewhere, like to store your the manifest you want to apply inside Kubernetes, well, you will have somewhere the base 64 version of all your secrets, and we do not want that. So we have a lot of tools to do that. So we have already talked about external secret. So we have this really weird race condition we have to know about. But to be fair, it only happened to me like twice or thrice. So I think it's a good way to start because this issue does not, and it's a trade-off. You have to know that it can happen, and you have to know if it's really important for you that it does not happen or not. You can also like minimize the impact of that using what we call the reloader. The reloader is a tool that you will use and that will check the secrets and saying, oh, the secret was up to date, so I'm gonna restart all the pods. And so even if the race condition happens, since the secret is updated after the app is deployed, it will be redeployed again with the good version of the secret. So that's I think that's a good way to mitigate this issue. But it's not the only way like to manage secrets inside Kubernetes. There is another operator that is really famous, which is called sealed secrets. Kind of works like Ansible Vault. For those of you who know it, basically you install the controller inside your cluster, and when you want to create a secret, you say kube seal the secret name, the value of my secret, and it will generate a sealed secret manifest containing an encrypted version of the secret that this time is not decryptable only by base 64, and you can actually version this sealed secret inside your Git provider and like deploy the sealed secret inside your cluster, and the sealed secret controller will make sure to make it a secret that is usable by a pod. This issue, the main issue I have with this is that it's kind of a bit more difficult to use for people that are new to Kubernetes, and the encrypted version of the secret that is created inside sealed secret depends on the cluster. So that means that if for any reason, like you lose your cluster and you have to redeploy everything again, the sealed secrets manifest will not work in another cluster. So you still have to like store the value of the secrets somewhere else, which is probably a secret manager. And so I prefer a way that leverages the secret manager than having this manual action, which is I have to take the secret from the secret manager on my local computer, because it kind of defeats the purpose of a secret manager to copy the data on my local computer at some point. And so you have other ways to do that. Arthur, the next Kube Talks, will probably show you the little tool he developed, which is basically a shim. So it's something that you run as entry points of all your workloads inside Kubernetes, and it will look for in your code and in your configuration files, it will look for references to secret managers secrets. And so each time it will find a secret manager secret, it will call the API of the secret manager and like replace the value by the actual value. So that means that you can that you will store all of your configuration using only references to secrets stored inside Secrets Manager, and it's at the start of the application. Yeah, sorry, Arthur. And at the start of the application, the value will be replaced. But yeah, come to Kube Talks. He's gonna talk about this like for half an hour and way better than what I'm doing right now. And so there are other ways to do this with sidecar inside of your pods. Always making sure that the value that it's stored in a file is the one stored inside the secret manager. So you have like hundreds of ways to do your secret management in Kubernetes. There is no like ideal solution, because if there was one perfect solution, everybody would use it. So you have to find the one that works for you.
That makes sense, right? And the one that's going to work for you is not necessarily the one that's going to work for someone else, right? I would caution, and I would caution this in every instance ever, because again, I'm an old crusty sysadmin, to not reinvent the wheel. Yeah. Right? Friends don't let friends write secret managers. So don't do it. There's a lot of options out there, and just pick one and roll with it. It's software, so it's all trade-offs. Find the trade-off that gets you the thing you want for the pain you're willing to accept, and move on to the next problem.
Yeah, that's right.
So you mentioned, and Arthur also mentioned the talk coming up. We mentioned Kube Talks, however you want to pronounce this. So for those of you who are watching for the first time, maybe don't know what this is. Kube Talks is Scaleway's talk series, do meetups. We've been doing it for a couple of editions now, where we get basically a community together, we talk about Kubernetes. It's not unlike Call Dr Kube, except instead of being online, it's in person. So very similar format.
Good old way.
Yeah, exactly. So if you're interested in when we have those events coming up, where they are, for now they're just in Paris, but we're going to be expanding the model. Check out, and we'll get Diego to put the URL up on the screen, scaleway.com/events or /en/events, depending on your localization. And you can check out there all the events we've actually got coming up, including Kube Talks. And of course, Arthur will be speaking at the next one. I also got the Jam, which is a meetup series that we've been running for quite a while now, that I MC. So if you like the sound of my voice, my dulcet tones, please come through and check that out as well. But for the next Kube Talks, Arthur, of course, going to be talking about secrets and race conditions and all that good stuff, right? And we've also got Etienne Fauchot, is the CTO at Skyloud. I think it's Skyloud. Sorry, Etienne, if you're watching. He's going to be talking about GitOps. Yes, GitOps, I remembered. We'll be talking about GitOps. So if these are topics that are interesting to you, please come through. If you're in Paris, and that's going to be on 30 May, I think. Yeah. 30 May, right? So if you're in Paris on 30 May, please come through. Registration is mandatory, but it costs nothing. Also, it would be helpful if you spoke French, because the talks will be in French, because welcome to France. So, right. All right, so super. Thank you for reminding us about the Kube Talks, Arthur. Super appreciate it. So there we go. Okay, we've got 10 minutes left. I think that's enough time to talk about one more question. If you got time, Sacha, if I can
Yeah,
impose
of
upon you
course.
for one more question. Do we want to talk about Kubernetes controllers and operators? Do we want to talk about Argo CD? Or do we want to talk about how could developers test changes when their
Let's go
development
with
is done?
with controllers and operators.
All right, so here's the question. What is the difference between a Kubernetes controller and a Kubernetes operator? How do I write a Kubernetes operator? Should I write a Kubernetes operator?
Yeah. So controllers and operators are like components that are responsible for managing and maintaining the desired state of resources within your Kubernetes cluster. They both do that, but there are some differences. Otherwise, we wouldn't have like two naming conventions. So a controller is a component, a core component that monitors the state of a resource and that ensures that the desired state matches the actual state of what it is deployed. It's like it follows a reconciliation pattern. The comparison I like to give is like the cruise control mode of your car. Like you say you want to go to 70 kilometers per hour. Well, there is like somewhere in your car a loop continuously checking your speed, and at some point, if the speed diverges, it will either speeds up or slows down the car. Well, everything in Kubernetes, every resources in Kubernetes works the same. Like you have a resource, you say, I want my resource to be deployed this way, and you have like a loop somewhere checking continuously that it's what it's deployed.
So this sounds, if you're familiar out there in the internet world with observability, there's little o observability, which is the thing that Datadog and Honeycomb want to sell you. And then, right, and there's big O observability, which is the theory behind it, right? And the idea is that you have controllers and state machines and so on and so forth.
Yeah.
And this is precisely what they're doing, right? You have information that's coming in, it's being processed, and a decision's getting made, and then data's flowing back out of it, right? And the idea is if you're trying to maintain state, in the case of cruise control, the state is of the vehicles moving at 70 kilometers an hour. Yeah. But of course, there's a lot of things that want to stop that from happening, right? Like the air, for example, wants to stop that from happening. And so, you have to have, as you said, like there's some sort of decision-making box, right? That the information's coming in, it's coming back out, and it's measuring these deltas, and it's the deviations of these deltas, and it's making a ton of little decisions. And the granularity of these decisions is going to affect its ability to maintain that state, or at least to report on that state, and so on and so forth, right? And that's kind of what I want to drive at there, granularity, right? If we're talking about this, and we say we want to try to maintain this state, or we want to try to report on that state, is that something that can be done? Like, is that a thing that's going to be pulled every 15 minutes? Is it a thing that's going to be pulled every second? Like, what's the granularity on that?
Well, so it's basically like it's like a queue. So it's a queuing system. So each time, like for instance, you have like your resource, it goes through the controller loop, and then it gets back into the queue. And at some point, like the controller, it just like takes stuff from the queue, do the reconciliation loop, and puts it back inside its queue. So sometimes also, if you're creating your own controller, there are like some options where you say, I don't want to put it like back to put it back in the queue like right now. I want maybe to wait 15 seconds or an hour, or I don't know. It depends on the logic of your controller, but it's always at some point gets back in the queue, and there is like no exact timing I can give you.
That's fair. I mean, if at the end of the day, there isn't an exact timing, that in fact, the reinjection into the loop is itself part of the logic of the controller, then
Yeah.
that's a completely relevant, completely reasonable answer, of course.
Exactly. And so you have two types of controllers. You have like the built-in controllers. So for instance, the pod controller, the replica set controller, the deployment controller. So basically, each resource that you're used to use in Kubernetes has its own controller. And you have also like custom controllers, because as you know, so we already said that, but Kubernetes is an API, but it's an extensible one. So basically, we have like the resources we all know inside of Kubernetes, but I can also create what we call a custom resource definition, which will basically add a new resource to the Kubernetes API. And so as the pod will work with a controller, like my resource, for instance, we've talked about external secrets, so external secret will come with its own controller to reconcile the state of the external secrets that I've declared inside the cluster. So those are the two types of controllers. Operators are a set of resources, custom resources, and controllers, mostly custom controllers, that will work together in order to achieve a more complex goal.
Fair enough. But we were lucky. We actually had when Arthur was on, we actually had a whole. We went right down this rabbit hole and talked at length about that. So if you're watching this episode and you're like, wait a minute, we've only got a few minutes left and we're just getting good. I want to talk more about controllers and operators. Go watch the previous Ask Dr. Kube or Call Dr. Kube, because we actually spent a good 15, 20 minutes on this topic, even longer. We spent a good long time on it. So
yeah,
definitely check that out
on YouTube.
It's always available on YouTube.
That we have created or recorded there, so be sure to check it out. And we have a playlist.
Yeah, so while Diego gets that playlist set up, a couple of things and put on the screen for us. A couple of things just want to plug, of course. Sacha, you wanted to mention, and you already mentioned it a little bit, but I want to give you an opportunity to talk a little bit more about it. You've got an open source operator. So we talked about operators. Right, you've got an operator. You mentioned at the very start. Why don't we talk a little bit about just give us an overview? What's the operator called? Why did you develop it? What's the use case?
Okay, so the operator is called Burrito.
Like the food.
Like the food, yeah. Like the food. Why? Because it's what we call a tacos. So a tacos is something. It's a Terraform automation and collaboration software. So it's a kind of software that was theorized by the community for helping you handle your Terraform code bases. So what we want with this software is it handles drift detection of your layers, so it makes sure that everything is up to date, that everything has been applied, and that there was nothing done manually inside the console. It helps you with your contribution workflow. So basically, when I open a PR or an MR on my Terraform code base, I want maybe a plan to run, and I want the output of the plan to check that it does what I want it to do before merging my PR and running the workflow. I also want to have secret and environments variable management, Terraform version management. I also want access control, because maybe the people who can contribute to the Terraform code base are not the one who should be able to plan it, and those are not the one who should be able to apply it. So all this kind of stuff. At Padok, since we are specialized in the cloud, we work a lot with Terraform. And at some point we felt the need to use this kind of software, but in the open source community there are some experimental stuff that do maybe only the drift detection, or maybe only the contribution workflow through PR and MRs. And you have the SaaS solution that works perfectly fine, but are way too expensive. And since we are Kubernetes experts, we ask ourselves, okay, maybe we are used to use all those tremendous tools and operators from the ecosystem, maybe it's time we try and contribute to the ecosystem, because we actually see that there is something missing there. So we've started working on that a few months ago with a colleague. To be fair, it's still experimental, but it works fine for the functionalities we have implemented. So go check it out on our GitHub pages, and try it out and give us feedbacks.
Excellent, excellent. All right, so we are at time. I want to make sure to respect everyone's time. And the last thing I want to mention before we go is that if you're into Kubernetes and you watched up to this point, so you probably are, and you want to get more information, more good news about what's going on, good tools, what's going on in conferences and meetups, you want to see the hottest new open source projects, you want to know when the next Call Dr. Kube episodes are coming up, you want to connect with a broader community, feel free. We invite you to subscribe to our Kubernetes newsletter. It is put together by Eli, who normally would be joining us today, but is feeling a little under the weather. So hope you're feeling better soon. Edited by Eli. Monthly, we send that out so you don't have to stay glued to social media just to get the good news. You get all in your inbox right at the end of the month. And you get a nifty crossword that goes along with it, a Kubernetes themed crossword every single month, handcrafted. None of this is AI LLM nonsense. This is a real crossword made by an actual human. So definitely check that out. It would make us all very happy, and let Eli know that you like their crossword.
And it's called Behind the Helm.
And it's called Behind the Helm because, of course, we love a nautical pun when we're talking about Kubernetes. So we got the URL up on the screen there, covering Diego's face. So thank you for your sacrifice. Appreciate that. All right. So that's it for us. Sacha, thank you so much for coming through, for volunteering. If you've noticed, previous Call Dr. Kube episodes, the doctor has worn a lab coat. I tried to get the lab coat out to Sacha in time for this episode. It did not arrive. So, Sacha, we'd love to have you come through on a future episode.
You need to come back.
With the lab coat.
Exactly, with the stethoscope and everything. No problem.
It would be my pleasure.
Super. Thank you so much. So thank you again. Thank you to everybody in the chat. Thank you to everybody who sent in questions, of course. And thank you to everybody that just watches. We really appreciate you coming through. So until next time, keep it safe, everybody. Bye-bye.
Bye.
Bye.